Picture a frozen, windswept expanse.
Yeah.
Right? It's the height of the Ice Age. And out of the swirling snow steps this predator straight out of a campfire legend. It's massive, heavily muscled, and, built specifically to take down giants.
Oh, yeah, the classic mythical beast.
Exactly. For a lot of us, the second we hear the words dire wolf, our brains instantly conjure up pop culture. We picture these monstrous beasts guarding medieval castles on premium cable, or, we imagine the ultimate big bad wolf roaming the prehistoric tundra, just twice the size of anything alive today.
Right, just a scaled-up monster.
But what if almost everything we've absorbed about this legendary predator is just, completely backward? Welcome back to another deep dive. Today we are on a mission to settle the ultimate canine showdown. We are unpacking a genuinely mind-bending video from the YouTube channel Apex Truth, putting the dire wolf up against today's gray wolf to see what the actual biological record tells us.
And, the contrast between the myth and the biological reality is just staggering. Our focus for this deep dive is to map out the sheer evolutionary divide between these two predators. We really need to look at why one of them survived the most grueling climate shift in recent planetary history, while the other vanished completely.
Right.
And perhaps most controversially, we are going to look into a modern scientific effort to actually bring the terrible wolf back from the dead.
Okay, let's unpack this, because before we can even get into how they hunted or who would win in a fight, we have to shatter this massive foundational misconception about their family tree. The prevailing narrative, like the one I definitely believed before watching the Apex Truth video, is that the dire wolf and the gray wolf were essentially brothers.
Right, yeah.
Just a scaled up, heavyweight, older brother and a leaner, younger brother, basically.
Yeah, and I mean, that assumption makes total sense when you just look at their skeletons side by side in a museum. Visually, the fossils share an incredible amount of architecture. But a groundbreaking DNA study published in 2021 completely destroyed that narrative.
Wait, destroyed it how?
Well, by extracting and sequencing ancient DNA from dire wolf remains, geneticists discovered that the dire wolf and the gray wolf are not brothers at all. They actually last shared a common ancestor roughly 5.7 million years ago.
Wait, 5.7 million years? That is an incomprehensible amount of time for two lineages to drift apart. I mean, to put that in perspective, human beings and chimpanzees diverged around, 6 or 7 million years ago?
Yeah, exactly.
So you're saying a dire wolf and a gray wolf are about as related as we are to a chimp?
What's fascinating here is that the genetic distance is certainly comparable. The divergence happened because of sheer geographic isolation. You see, the dire wolf lineage evolved entirely in the Americas. They were locked in this massive, isolated ecosystem for millions of years, which allowed them to branch off into a completely unique genus. They aren't even categorized as Canis, which is the genus that modern wolves, coyotes, and our domestic dogs belong to. The dire wolf was classified into its own genus Aniscion, which literally translates from Greek as terrible wolf. The gray wolf, meanwhile, evolved an ocean away in Eurasia.
So the gray wolf didn't even show up in North America until much later.
Long after the dire wolves had already claimed the entire continent as their undisputed territory. Gray wolves only crossed over the Bering Land Bridge much later in the Pleistocene epoch.
But hold on, if they evolved completely separately for almost 6 million years, how did they end up looking so similar? I mean, if you put a dire wolf skull next to a gray wolf skull, they look like they belong to the same species.
It is a textbook example of convergent evolution, when two entirely different animals are presented with the exact same environmental problems, in this case, surviving a freezing climate and hunting large prey nature, often arrives at the exact same physical blueprint.
Like how a shark and a dolphin look remarkably similar.
Exactly. A streamlined, torpedo-shaped body is just the most efficient way to move through water, but one is a fish and the other is a mammal. The dire wolf was a completely unique evolutionary experiment that just happened to look like a wolf.
That makes the reality of their coexistence so bizarre to me.
Yeah.
They eventually lived side by side, hunting in the same snow-covered plains of North America, but they were literally so genetically alien to each other that they never mingled. That's like finding out lions and house cats are less related than we thought.
Yeah, I know. But the DNA evidence is completely conclusive on that front. They shared the exact same geographic landscape and competed for the exact same resources, but there is zero evidence of hybridization. The genetic drift over those 5.7 million years fundamentally altered their biology,
Right.
Their immune systems, their reproductive timing, perhaps even their pheromones and mating behaviors were so incompatible that a gray wolf wouldn't even recognize a dire wolf as a potential mate.
Because they evolved with completely different toolkits, the way they physically interacted with the world had to be totally different too. The video does a great job breaking down their physicality, and it proves this isn't just a matter of one being a slightly scaled up version of the other. Picture a dire wolf as a heavyweight wrestler built for a cage match, while the gray wolf is an ultramarathon runner built for endurance.
The biomechanics of their skeletons perfectly support that analogy. First, let's look at the sheer mass. The dire wolf wasn't quite the horse-sized monster of fantasy television, but it was still incredibly formidable. On average, they weigh between 130 to 150 pounds, roughly 60 to 70 kilos.
Wow.
That makes them about 25% heavier than today's average gray wolf.
A 25% increase in pure muscle mass on a predator is a massive mechanical advantage.
Huge, but the weight distribution is where the wrestling analogy really holds up. Dire wolves had much shorter, remarkably thicker leg bones. They had smaller feet, a wide barrel chest, and a very low, compact frame. When you lower an animal's center of gravity and thicken the bone shafts, you are building a body explicitly designed for leverage and brute force.
Right.
You don't use that body to sprint for 3 hours across the open tundra. You use it to grapple.
They were built to anchor themselves to the ground.
Mm.
Whereas the gray wolf, even a massive one that might hit that 130-pound mark, carries that weight completely differently. They have long, spindly legs. They are lean and tall. They are built to trot for 50 miles, tracking a herd, just waiting for the prey to exhaust itself from the chase. It really is stamina versus impact.
And nowhere is that emphasis on raw, concussive impact more obvious than in the dire wolf's skull architecture. They possess these massive, heavily reinforced cheekbones called the zygomatic arches. These arches serve as the physical anchor points for the temporalis muscle, which is the primary muscle responsible for closing the jaw.
So mechanically speaking, if you have a wider, thicker cheekbone, you can attach a much larger, thicker muscle to it.
Precisely the underlying geometry. A larger temporalis muscle pulling on a reinforced jawbone acts as an incredibly efficient lever. This allowed the dire wolf to generate an estimated bite force of over 1,300 newtons at the canine teeth. To put that into perspective, that is the strongest bite force of any known canine, past or present.
1,300 newtons. The Apex Truth video highlights that this kind of pressure isn't just for slicing through hide or muscle. That is literal bone-breaking power.
The fossil record vividly confirms that. Their canine teeth were thicker at the base, meaning they could withstand incredible bending and twisting forces without snapping off in a struggle. When paleontologists examine dire wolf teeth, they frequently find heavy wear patterns and microfractures.
Oh, wow.
Yeah. This tells us that, much like modern hyenas, dire wolves were routinely chewing straight through dense bone to access the nutrient-rich marrow inside. Gray wolves, conversely, possess sharper, narrower teeth. A gray wolf's bite is still powerful enough to bring down a moose, but it's fundamentally adapted for slicing meat and severing tendons, not pulverizing femurs.
But having a 1,300 Newton bite force doesn't explain the whole picture, right? Why would an animal need to evolve a bone-crushing cage fighter build just to survive? You don't need a reinforced jaw to catch a rabbit.
You don't. The physical adaptations of the dire wolf are a direct reflection of the prey they were forced to hunt. The Pleistocene epoch in North America was a landscape dominated by megafauna. We are talking about ancient horses, massive prehistoric bison, giant ground sloths, camels, and even juvenile mammoth.
It was a world of giants.
And the dire wolf specialized entirely in hunting those giants. When you are trying to wrangle a struggling multi-ton herbivore to the frozen ground, a tall, lean runner's body is just going to get crushed underfoot. You need that heavy, stocky, low-to-the-ground build to latch onto the prey and use your own body weight to drag it down.
But even with a 150-pound, heavily muscled frame and a jaw that can snap a femur, the math still doesn't quite work for a solitary hunter. A single wrestler can't take down a mammoth. They must have had to multiply that force, which means they had to be incredibly organized.
Social structure is arguably the most critical weapon any canine has. We know modern gray wolves live in highly structured family groups, using complex communication and cooperative strategy to hunt prey much larger than themselves. While we obviously can't drop a camera into the Pleistocene to observe a dire wolf pack, we can reverse engineer their social lives by looking at their biology.
The video brings up a fascinating forensic clue here: low sexual dimorphism. Can you explain how bone sizes actually tell us about their family structures?
It comes down to reproductive competition. In species with high sexual dimorphism, where the males are drastically larger and more heavily armed than the females, like lions or gorillas, the social structure usually revolves around a single dominant male, violently fighting off rivals to control a harem of females.
Right, you need to be huge to win the fight.
Exactly. But in the dire wolf fossil record, the males and females were very close in size. They had low sexual dimorphism. Across the modern animal kingdom, when males and females are roughly the same size, it heavily correlates with monogamous pair bonding. The males don't need to be massive because they aren't constantly fighting each other for mating rights. They are cooperating with a female to raise offspring.
That makes sense.
This strongly suggests dire wolves lived in cohesive family packs led by a mated pair, functioning as a highly coordinated unit.
And there's a much darker piece of evidence that proves they were swarming these giant herbivores as a team. The La Brea tar pits in Los Angeles, I mean, they haven't just pulled one or two dire wolves out of that asphalt. They have excavated the remains of thousands of them.
The mechanics of the La Brea predator trap paint an incredibly vivid picture of their behavior. These natural asphalt seeps would get covered by a thin layer of water or leaves. A massive herbivore, say a giant ground sloth, would wander in and get hopelessly stuck. As it panicked and thrashed, it would emit distress calls.
It's basically ringing the dinner bell for every predator in a 5-mile radius.
But a lone predator might be cautious. The fact that we find entire clusters of dire wolves trapped together suggests they were responding to these distress calls en masse. They were hardwired to rush in as a pack, and they had to, because an easy meal in the tar pits would also attract other terrifying apex predators like the American lion or the saber-toothed smilodon. To defend a massive kill from a smilodon, the dire wolves relied on overwhelming numerical superiority.
Which highlights a major vulnerability. The dire wolf relied on sheer force and massive pack numbers to tackle giant prey. But a gray wolf pack is incredibly dynamic. If a gray wolf pack is hunting an elk, they group up. If times get tough and they are forced to hunt hares or mice, they can easily splinter off into pairs. They tailor their social structure to whatever the environment provides.
The dire wolf simply did not have that flexibility. Their bodies, their metabolism, and their hunting strategies were so intrinsically tied to pack dominance over megafauna that a lone dire wolf, or even a pair of them, would struggle immensely to sustain themselves. They required a massive caloric intake, and you cannot meet that caloric threshold by hunting field mice. The rigidity of their social needs matched the dangerous rigidity of their diet.
Which sets the stage for a biological tragedy. They built the absolute perfect machine for hunting giants in the freezing cold. But around 12,000 years ago, the environment flips the script. The Ice Age ends, the giants disappear, and the dire wolf is caught in the ultimate evolutionary trap.
If we connect this to the bigger picture, extinction is rarely just one event. It is almost always a cascade of ecological failures that a highly specialized species simply cannot adapt to. Biologically speaking, extreme specialization is a fantastic strategy when your environment is stable. You become the undisputed king of your specific niche. But the moment the climate shifts, your greatest strength becomes a fatal flaw.
So let's trace this cascade. The climate rapidly warms, which fundamentally alters the vegetation across North America. The massive herbivores, the mammoths, the giant horses lose their food supply and start dying out.
Which immediately removes the primary fuel source for the dire wolf. But the climate wasn't the only pressure. This timeline perfectly coincides with the expansion of early human hunters into the Americas.
Humans who are highly intelligent, cooperative, and hunting the exact same massive herbivores the dire wolves rely on.
Precisely. So you have climate-driven habitat collapse, compounded by a hyper-efficient new predator accelerating the decline of the megafauna.
And, as if starving and dealing with humans wasn't enough, this warmer climate basically unlocks the gates for gray wolves and coyotes to spread deeper and deeper into the dire wolf's historical territory.
And these smaller, leaner, highly adaptable generalists just flood the ecosystem. Gray wolves are perfectly content eating a beaver, scavenging a carcass, or foraging for berries if they have to. They can survive on a fraction of the calories, and they can thrive in much smaller family units. They simply outmaneuvered the dire wolf in a rapidly shrinking arena.
But there is one final invisible nail in the coffin that absolutely blew my mind when I watched the video. Because the dire wolf was marooned in the Americas for nearly 6 million years, they were genetically isolated. When the gray wolves, the coyotes, and the early domestic dogs brought over by humans started mingling in North America, they could all interbreed.
Yes, and hybridization is a powerful survival tool. When gray wolves and dogs interbred, they shared useful genetic traits, most notably alleles related to immune system defense. They were essentially trading biological software to fight off novel pathogens.
But the dire wolf couldn't interbreed with any of them. It was completely locked out of the genetic exchange program.
That genetic isolation left them incredibly vulnerable. As humans and migrating canines introduced new diseases into the continent, the dire wolf lacked the genetic diversity to adapt. So you were looking at a hyper-specialized predator, starving from lack of prey, being out-hunted by humans, outmaneuvered by adaptable coyotes and gray wolves, and quite possibly ravaged by novel diseases its immune system had never encountered. It is the textbook definition of an ecological collapse.
They lost the evolutionary lottery 10,000 years ago, and the terrible wolf goes quiet forever. Or so we thought. Here's where it gets really interesting. The Apex Truth video brings us to the present day, where human science is attempting a highly controversial rewrite of history. Enter colossal biosciences.
Yeah, colossal biosciences recently ignited a massive debate with a staggering announcement. They claim to have created 3 functional, living canine pups that represent the first tangible steps toward a dire wolf resurrection. These pups, named Romulus, Remus, and Kezi, were born in late 2024 and are currently being observed in a private wildlife reserve.
But we need to clarify the science here, because this isn't Jurassic Park. They didn't find a prehistoric mosquito trapped in amber and clone a perfect dire wolf.
True cloning requires an intact living somatic cell, which degrades quickly after death. You cannot clone a creature that has been dead for over 10 millennia. Instead, Colossal utilized incredibly fragmented ancient DNA recovered from a 13,000-year-old fossilized tooth. Using that ancient genetic blueprint as a reference map, they deployed advanced CRISPR gene editing technology. They took the embryos of modern gray wolves and artificially swapped out 20 specific genes to match the ancient dire wolf sequences.
So they essentially went into the gray wolf's biological code, found the lines of code responsible for certain traits, and just replaced them with the dire wolf's code. And the video notes that these 20 genes control major physical traits: bone growth, skull shape, coat texture, and overall body size. Even as pups, Romulus, Remus, and Casey are showing noticeably chunkier builds, much broader heads, and thicker fur than any normal gray wolf pup.
The physical results are undeniable. Colossal has also made it a point to consult with indigenous groups to ensure the project respects cultural and ethical boundaries regarding the land and the animals, which adds an important layer of modern stewardship to the project.
It's fascinating, but I have to push back on the premise. If they only edited 20 genes and the entire rest of the genome, like over 99% of their DNA, is still technically gray wolf, can we genuinely call this a dire wolf? Or did we just genetically engineer a gray wolf into wearing a highly convincing, bone-crushing dire wolf costume?
You have just summarized the exact debate raging among paleontologists right now. Critics argue that editing a tiny cluster of genes is not true de-extinction. By swapping those 20 genes, you can recreate the visual phenotype, the chunky build, the heavy skull. But you are completely missing the genotype's dark matter. You are missing the millions of non-coding regulatory elements, the complex genetic interactions, and the behavioral instincts that actually made Anacine a distinct living lineage.
It's an imitation, a biological tribute act.
Many scientists feel exactly that way. However, Colossal Biosciences views this as a vital proof of concept. They are using a relatively close proxy, the wolf, to refine their multiplex gene editing techniques before they tackle their much larger, far more complex ambitions, like restoring the ecological roles of the woolly mammoth and the dodo. They argue that even if it's a proxy species, introducing a specialized apex predator could help restore balance to modern ecosystems that are severely degraded.
It is wild to think about what happens next. So if we take a step back and look at this entire 5.7 million year journey, it really reframes how we view strength. We started with a canine lineage that got locked in the Americas and evolved into the ultimate bone-crushing heavyweight champion of the Ice Age. A predator that hunted mammoths in highly organized packs, dominated the landscape with a 1,300 Newton bite force, and built a body so perfectly specialized for giants that it couldn't survive when the giants fell.
The dire wolf is a magnificent, tragic lesson in evolution. Specialization provides incredible power in the short term, but adaptability is the only true guarantee of longevity.
The gray wolf won the survival lottery, not because it was the biggest or the strongest or the most terrifying. It won because it was perfectly content eating a mouse or a handful of berries when a moose wasn't available. Survival is about flexibility.
And while the prospect of utilizing gene editing to recapture lost biological traits is a marvel of human ingenuity, it serves as a powerful reminder of how delicate ecological balances truly are. When the climate changes, the specialists fall first.
Think about what that means for us today. The gray wolf survived the harshest climate shifts in history, simply because it was highly flexible and didn't tie its fate to one specific resource. So, what does our modern obsession with spending millions of dollars to genetically resurrect highly specialized, extinct mega predators say about our own understanding of survival in an incredibly rapidly changing world? Are we just trying to recreate the very specialists doomed to fail again? Something to mull over until next time. Thanks for joining us on this deep dive.